My name is Ingi, and I'm going to show you how to build a to-do app in Plang. There's a previous video where I go through this process quite quickly. So in this one, I'm going to go a bit slower. I'm going to explain how things work, how the code is built, where the source code is, how the database is, and so on. I assume that you've already installed Plang and set up the ID. There is a video actually how to do this also available. I'll link that in the comments. And what we're going to do is we're going to build this little to-do web service. It kind of covers the basic things that you would need to build apps. We have database access, we have web servers, we have what we call goals, which would basically mean function or methods in regular operational program languages. We have variables, and we'll be working with date and time a little bit in this example. We'll receive web requests, we will validate and do some error, and we will insert into the database and respond to that web request, and then we'll use Plang for testing. So we'll start by creating the project directory. This is just a folder, there is no config or anything like that. You just create a folder, and I have already a folder here called to-do. So the first thing that we're going to do is going to set up the table structure for our application. So we will create the setup.goal. This file runs each step only once. So when I say step, the title here, this defines a goal. A goal file can contain one or more goals. It usually starts with the same name as the file name, and then each step inside of those goals starts with a dash. And here we are basically telling it to create a table to-dos. You can see it's not pure SQL. Plang, basically you just need to read your intent. Then when we compile this or build this code, we will send this step to LLM. We are using TTP4 for that at the moment, and it translates this into, in this case, into a create statement in SQL. Let's do that. One thing I wanted to point out is this right side menu here. You can either do in terminal command, you can do plang build. This would build the code. Let's say this. Or you can use this where you can see it's not built yet. You can click this and then it kind of pops up and it builds it. Now the build here was relatively fast. This is because I've built this before on my computer, and we cache the LLM requests because this is expensive, so we want to kind of cache that. So you can see here on the right side, this changed a little bit. We have a link here to the documentation of this module. This module is what we call DB module. So if I describe the build process, it basically takes this step and it sends this text to TTP4 or the LLM. It also sends a list of available modules and asks the LLM to suggest modules to use to build this step. In this case, it chose to use the DB modules. Looks kind of obvious that this is some kind of a database action. After it receives that it should use the DB module, we actually send another request to the LMM with a list of all the functions that are available in the DB module, and ask the LLM to select the correct function and what parameters to inject to it. So we have here documentation. So this is where you can kind of see what you can do with this module, how you can use it. You can write select statements. You don't really need to be proficient in SQL. You can say select everything from task, not completed tasks and such. It will kind of figure out how to convert that to SQL. You have transactions, you have update and delete and all kinds of stuff. Now we have also here a little bit advanced documentation. This kind of describes how we are mapping the statement into actually a function or a method inside C#. So underlying code is actually C#. So we can see this here program.cs is actually the code that it's going to map to. So if we had there this statement here, this is calling the create table function. So we should have here somewhere create table, here it is, which receives a SQL into it, and then it executes that SQL. Now, as you can see from here, you can see that there is a SQL, it calls the function, and the parameter is SQL. Now we can also click here to open up the PR file. So the PR file is actually the build file, so kind of pseudo language, Plang runtime file. And here you can see the mapping. So it calls this create table, and these are the parameters. It's a string parameter, name is equal, and this is the value. Here below you can see the statement, that this is your statement that you wrote in the setup. And this is the request, the LLM request that we made to generate this response. So this is the system prompt. We tell him here you have to return in JSON, function name, so you can see that this part here maps perfectly into this part here. So you can always see what the statement is. Here you can see this is available functions. So you create data source, we have here somewhere create tables. And the user content is basically your step. We are using GDP4 for this, and we are caching this. And yeah. So now that we have this step built, we need to run it. And the reason we need to run it is because we want to create this table in the database before we start to kind of generate all the other code. Because when we start to create select statement somewhere else in our code, we want to be able to retrieve the database and retrieve those tables and see what columns there are. So let's run that. You have in the terminal, you have the option of run. You have or nothing. You can do this. The defaults to run. You can also do exec, which is basically build and run. Build will build the code, and nothing or run in front will actually run it. So we can see that it actually started and ended immediately. Now, if you look at the folder structure of the folder, we can see we have here .build and we have here the .db. So .build, we can see we have setup, so that maps to this. And then we have the goal file, so reference to this goal file. We can see that the goal name is setup. We have the step here. The module type is here. We have a name given to it. We have a description given to it. This can be useful sometimes later. And here are some relative path, if it should be executed, if it should run once. So everything in the setup file will only run once in the lifetime of the application. And this is managed by the system SQLite database. We'll see that a little bit. Date when it's generated. Wait for execution. This is kind of for run and forget. And we can have some error handlers, retry handlers, cancel handlers, and so on. And here we can see the LLM request that was done to kind of generate this code. So you can always see how the request to the LLM is behaving. Then we have some other kind of paths that are here, and we have hash of the of this goal. If it's generated, signature for now is null. The future is hopefully in the future we want to kind of sign the code so we can always validate that it's correct. Now create to-dos table PR. We already looked at this. This is what we clicked here on. So I'm not gonna go into that. Info is simply a GUID with the application ID, nothing else at the moment. We have here in the DB folder, we have two databases. So one is system SQLite. This contains any kind of settings we have. This maintains, for example, everything that should run once and stores the value or stores the what has actually run. So if I add another step into my setup folder, it will add another object into this JSON here. So now the application knows that it has run this step. So if you need to run a step again, you would have to remove from this value. You have some other things here. You have here the database connection. So this is basically telling you that the database is located here in the data SQLite, located in DB in data SQLite, which is this one. This is default for all apps. If you're not defining or injecting your own kind of SQL driver into this, because Plang supports any kind of database you want, you just have to inject the correct driver. We have identities. So this is identity. This is basically kind of public-private key kind of thing. And you can see all the data there. Kind of this is the data that is there. Okay. Then we have the encryption key. So that's another thing. You can encrypt content kind of easily. So and then we have the data SQLite, and there we have __ events. This is for event sourcing. This is very interesting, and we're not going to go into it right now. And then we have our to-dos table, which has our columns that we created. One thing to note is that we are not defining ID here. We are allowing Plang to actually handle the ID creation. And this is important for event sourcing of the application. And event sourcing allows us to basically sync data between multiple devices. The purpose or the reason for this is because we are keeping our data basically on our local machine. The reason why we can have cloud services It's not because we don't have enough storage on our hard drives. We have plenty of storage. Basically, the only reason for it is so we can, work on our task list in our computer and then go onto our phone and work on it there. The only way to kind of do this with current programming languages is basically to have this kind of centralized server where you kind of sync to. So this means that you need to trust some third-party service to store your data and store it securely and safely and all of that. But with Plang, since we are using event sourcing, all the modifications are kind of locked down. It's quite interesting technique. This allows us to sync our data between devices securely. So we encrypt it first on our computer. The receiving party actually has that same private key, so we can decrypt that data as well. This is something that is maybe a little bit later in the more you get into the programming language. Anywho, so we have here the to-dos table. We have the data, we ran it, so we are ready, we are done with the first step. Let's close this, and where are we? Okay, we ran this, and now we want to start the application. So start.goal is the default entry point, so you can run just Plang, and that's he will look for the start goal file to run. So we want to do this, and so it's the same as before. Start is at the top, that's the name of the goal, it's the same name as the goal file, and we want to start a web server. So let's build that. We can define here what we want, what the we can kind of define here. For example, we can say on port 1990, host is my host.com or something like that, and he will actually map this, and you can see now after we build this, we can see it's going to use the web server module. It's going to call the function name start web server, and here you can see the parameters that are actually going to be used. So you can see that it's port 8080, that's the default one. Host is localhost. The maximum content, so if you wanted to say like max content size, you can say 100 kilobytes or 100 megabytes or something like that. So you don't need to define this in bytes or something. You don't need to, it will figure it out for you. You can define the encoding. It's always UTF, or default is UTF-8, and sign request required. So that basically tells you that nobody can kind of contact the server unless it has a signed request. The public paths are default API, but you can define your own kind of public path. So this is kind of what options you have. And we'll see like in the future what you can add, what we'll be able to add to this, but this is kind of a good start, at least for now. So we started the web servers, that's good. So we're going to create the API folder, and as I said before, that's default public folder. So that means that anybody that makes a request to this web server, if he tries to access setup.goal, he will not get anything. Or if he tries to access start goal, he will not get anything because it's not in a public path. So API, and we want to create the new task goal. Okay, new task, and let's copy that and let's look at this. So when we start here, we start by saying, okay, make sure that this request.task and request.toDate. So the data that is being sent with a post, it's always contained in a variable request. So if you submit a JSON that is something like this, you would access the value like this. Okay. So make sure that these properties are not empty. The validation here is not really good. I mean, you should of course check if due date is date and so on. But you notice here I'll just say throw error. I'm not defining really what the error should be. Just say, you know, you figured it out, the LLM just figured it out, and you know, just throw an error. Then we say here insert into to-dos and then write out. So let's just build this and see what happens. So if you start here, so this is a conditional module. So as before, for each request, we start to find out what module to use. So finding module for make sure that this is, and then he decides, okay, I'm going to build using the conditional module, and then he builds around that. This actually creates a C# code. So I'm sorry about how crappy the layout is, but that's just how it is in VS Code. So you can see here there's a function called process. It gets the request in, request task, and request due date. It checks if it's null or null, throw, then the error is going to be task or due date cannot be null. Also, task or due date cannot be empty, and then it returns true. So yeah, it will throw an error here if it is empty. So next is insert into database. So what we do here is insert into to-dos, and we want to get the ID back. We say, write into ID. So it figures out that it should call the DB module. It should call the function insert and select ID of inserted row. And you see how descriptive the function name is. This is something, if you start to create a module, you want to kind of have the function name quite descriptive. It helps the LLM to kind of select the correct function. And then we inject the SQL, and these are the parameters. And even though we didn't define the ID is here. The Plang language kind of injects the ID here for you. The task, well, we have the task here. The due date, that's here. And then it returns this ID. So it writes into this ID variable. And then we simply just write out the ID, and that's the output module. Calls the function write, and the content is ID. So yeah, that's about it for the new task. Let's go into the next one. List.goal. Now we're getting a little bit faster. Got a little bit of the basics. So let's do this and let's build this. Okay, so as you expected, you can see how I just say select everything from to-dos. I'm not writing SQL really here, but it maps actually to SQL star to to-dos. And then write out to-dos. So since this is a web server, the output module actually outputs a JSON. So that's injected kind of output stream is JSON. This can then be modified by you. If you want to inject some other kind of output stream, you can do that. Or I might actually be lying there because I don't think it's supported, but in the code it's there, but it's not really supported. We don't allow it yet, but the foundation of the code actually allows it. Let's put it that way. Okay, so we have this. We want to build that. Everything is built. Okay, and now we can actually run the code. And one thing we have here is just estimate cost. So this is estimate cost of when you are building this for the first time. You don't have everything cached. You can ask the LMM these questions, map this code over to these modules in C#. This is kind of the cost of doing that. If you have OpenAI key, you can inject OpenAI module or service into Plang, and then you just go straight to them, and it's going to be a little bit cheaper for you. Well, half a price. We add double on top Plang. That's for supporting the development. So hopefully you choose that for us, so we can continue the development, because I think this is just awesome. Okay, let's create the test folder. We can of course do this in our favorite REST client, but now Plang is my favorite REST client actually, because all of them are they get too complicated. They've gotten too complicated. For some reason you need to register and all of that, which I really don't understand, but you know, it is what it is. Okay, we'll create the test. I'm gonna create also the one below, which is test list. And we're just done with that, and we can focus on code. Oops. Like this. And paste this in. So what we have here, we are gonna execute this post on this URL. Let's go back here. We're gonna execute this post on this URL /new task, which maps over to, let's close this, new task here, and we're gonna send in. Like we saw before, we had request dot. So if you open up the code, you see request dot due date. That's then the JSON request that is being sent, and we respond with the ID. So we write the ID actually into this variable called result, and then write out the result. One thing here in the due date, we say here now. So now is actually datetime object in C#, and you can access any property. So you could do, if you know C#, you can actually do this, and this would give you, the date format. You have these shortcuts of 2 days, in Plang. You can do 2 months, hours, seconds, milliseconds, and so on. So this is all documented in the, this is documented in the documentation. Okay, so I think we can build this. Okay, so let's actually run. So I'm just gonna run Plang, because we have a start.goal. We can just run Plang, and it starts to listen. Now we can run the test. And we get the ID. So the ID is basically this long number. In a normal way, when we have incremental ID, that would be like the first item would be 1. But since we want to have event sourcing, this is something called Snowflake ID. This is something Twitter made. It builds from the machine name, the time, and something like that. So you can which order item went into the database. So if you look at the database now, into the data, so look at we can see the ID here. We can see the do my homework and what the due date is. So, and if we look at the events line, we have here 2 actually lines. The first one is going to be the create statement of the table, and this is the insert statement we just did. We can see that it's already encrypted into the database, and there is a key hash here. So this data can then be synced between devices. Nobody can read what this is. They will need that private key, and this key here, key hash, is basically the hash of the key that was used, of the public key. So it's not displaying what the public key is, it's just displaying hash of the public key. So you will have to know what the public key is to be able to public key, and then of course the private key to be able to decrypt this data. Here we have a processed column, which just tells us if it's processed or not. Okie dokie. So we now have created this. We can then list this item, and we can see all the data. And like I said before, the output module is using the JSON output stream, so that's why it's in JSON. Okay, so if we look at it in the beginning, we created the database table, we started a web server, we learned what goals and what we would know as functions are variables, we worked with date and type, we handled the web requests, we did some validation and error handling, we inserted into the database, and we wrote out the response and created a couple of tests. Now this is not unit tests in the sense of like assert and such, but you know, we did some tests. So let's add a LMM connection into this. So what we want to do here is when we add a new task, usually when you have an application, you have to categorize it. You have to say like, this is for my work, this is for home, this is my hobby. You know, so it's extra click for the user. So we want to just make the LMM do this work for us. We don't want to do this, you know, we want to save this precious time. So what we're going to learn here is how do we modify the database, because we need to add a column. We want to know how to use the LMM, run and forget, and how to update the database, how to update the record in the database. So we're going to go into the setup goal, and we are going to add this column category. Now here you're going to see something that's very interesting. So now imagine you have this in, and you are adding or Git, or add this code and then into Git, committing it. This will give you really clear like diff of the code that is actually going to change. So that I think is going to be very interesting how that is going to develop. So let's build that. Again, we need to run the setup. And again, this is because we want to update the database before we start to do other kind of code things with the LMM, because the LMM wants to have all the columns in the database. So we open this and we can see the category is here. Excellent. So next. Okay, so new task. We open new task and we add this call categorize. We say don't wait. So let's take also categorize, have this everything with us, and then read this. So we can call other goals by simply saying call, and then you have this exclamation point, categorize. Exclamation point is basically to kind of help the LLM to notify, okay, when it starts with exclamation, this is going to be a call to another goal. You can skip it, but then sometimes it kind of doesn't give you the right thing. Don't wait, run and forget. What we're going to do here is going to ask the LLM. This takes often a couple of seconds. You don't want the user to wait. It should just happen in the background. So we're just going to say don't wait for this. or you can also say run and forget, run and forget. That's also fine. Okay, so if we go into the categorize goal, so now we can see for the first time we have multiple goals in one file. In the categorize goal, we have here this step. Now you see that this step is now multiple lines. It also starts with this bracket LMM. Now, the reason for this is basically to assist Plang Code to filter out all the modules to send to the LMM, to decide which module I should use. Instead of me sending, 25 modules over to the LLM and saying, okay, choose all of these, from the DB module, file module, the LLM just use that. And it basically just filters if it contains these 3 letters, then in a row, in this order, then it's going to select those modules to send to the LLM, and he will return back results. Those who know how to handle these LLMs, they usually have this system command where you kind of define what you want, and then you have your kind of input, the input you want to give. So here we are saying, okay, we want you to categorize the input by 3 categories: work, home, and hobby. And we want you to return to us in the schema of this. So when you define the schema, it will actually give you the response, and it will load this into this variable. So we can see we can actually use the variable immediately. So you don't need to say anything about, like, okay, now load this into some variable, then retrieve it, then, work with it. Just it's there immediately. Interesting thing also, you could also do something like this. You could say work, home, hobby, 1 or 2 codes, single quote or double quote, doesn't really matter. And this is not even legal JSON, but the LLM doesn't care, it understands what you mean by this. So, and then we could basically skip this. So, I'm just gonna keep it as it is because I have it, it's cheaper. Okay, and let's see, is there anything else we want to do? No, just we want to buy a Lego in the test, so I'm going to copy that here, and let's build this, and it's built, and we want to change this into Lego, build again. I don't know why I did that, but okay. Let's restart the server. So it gets the code. At the moment it's not hot reloaded, but it's almost there. It's very close to it. Because since everything is kind of using reflection and the files are basically JSON files, we can technically load everything on build time and reload everything. But it's not there yet. Okay, so we want to create a new task. So what it does, we just got the ID back, nothing changed from perspective of previous request. Let's see, when we get the list, we will now get the category hobby. The previous one we created, do the homework, that's still just null because we haven't really changed that, but we got hobby in the category of buying some Lego. That's kind of cool. So you can, by doing this, you can start to kind of structure data and ask the LLM to work with data and makes decisions on that data. So this is extremely powerful, extremely powerful. Yeah, I didn't talk about the update statement, but it's an update statement. So if you're familiar with that, we can see it's calling the update function, and the SQL is that, and these are the parameters. So yeah. So identity. So identity is quite a powerful thing. This is kind of the holy grail of if you solve this, which I think I have, it's brilliant. Let's just say it like that. So let's start by understanding what identity is. I have this article here where I go into kind of detail of it, but in a short, kind of quick kind of way. The reason why we have username and passwords to get into a website is because we need to find a user ID in the database. It's not really for us to kind of send you marketing email. That's a secondary thing. The reason is so, when you upload your document to a web service, that document some user ID, your user ID number 1. And user ID number 1 has this email and this password. So we go in, you type in your password, take that, and we match it with the data in the database. And if it matches a user ID, we know that these documents belong to you. So the identity is basically this user ID that we need to give you your information and not somebody else's information. Now what Plang does is basically it creates the identity on your computer. So the service doesn't really need to maintain this user ID. It doesn't need to, find it anywhere. It gets the ID from you, and only you can provide that ID. Only you can generate the data the ID would generate, and you can prove it that it's only you. The only way somebody else can do this is by stealing your private key. So that's the only weakness. There's just one weakness in this, and that's if they steal your private key. So let's check this out a little bit. So again, we are going to add identity into the to-dos. Okay. So here we have that. We can build that. I guess it's built. Let's run it. So we have the column. Look here, we have identity column. Excellent. Okay. And you can see here I added a string here. That's because one time the LLM created a serial or something like that. So sometimes it makes some mistakes or just doesn't know better. And then you can kind of help it and say, okay, I want it to be string, or I want it to be varchar. So okay. We actually did that. Okay, so then we are gonna go into events. So events are very interesting. You have to create events folder. Events are always in the events folder. So and then it starts with events goal. And in events goal, you define what you want to bind to. So in this case, we want to bind before each goal in API.star. We want to call check identity. Now, events goal at the moment cannot have multiple goals in it, so you have to create a new file. So check identity and goal. So copy that and like this. So let's check a little bit into the events. So before each goal in the API, you can say after each goal, you can say you can see for each step. So before each step, after each step, before application starts, before application ends. So these are kind of the events that are available, and you can see a list of those in the documentation. Now there's a bug here in the IDE. So when you are actually after you build it, you cannot see the results here. In this. Okay. So just like you said, it's still like empty here, but it's actually built. So we can actually see events, and we see here events goal. That's because this is a little bit different than the other goals, but and the IDE doesn't support it at the moment. But here are kind of the events that are happening. Okay, dokie. We are then calling identity. This is wrong name. Like this. So if identity is empty, then show error. Identity is a reserved keyword in the programming language. So you can always kind of access this ID. Now, this identity is actually hashed version of the identity. It's hashed and salted, and the salt is actually in your system data, and you can see it here. So this is actually the salt that is used to create that hash of the identity. Okay, so you're not going to see kind of your identity when you register on the server. You just see the hashed version of it. Okay, so let's change this. Let's add the identity into the insert statement. Close this. We have new task, and now we want to, when we save, we want to save the identity with the new data. And when we select, we want to select from where the identity matches. So we have this. Let's build that. Okay, we have here. Okay. So the server is up and running again with the new code, with now where the identity is inserted with everything, and we can now then run the test again. So let's test a new task. Okay. Now, what we didn't do any changes here. We didn't do any changes, and the reason for that is because for every get, post, delete, patch, any REST request, we actually sign the request, and with the signature comes your identity key. Now you would think that this is kind of privacy issue or anything like that, or something like that, you know. It is not, because for every app that you have your own, each app has your own identity key. So every time you create a new app, you have a new identity key. It's also very easy to generate a new one. So if you want to have a new identity key with every request, if you want to be that anonymous, you can very well do that. But okay, so we did our post here, and yeah, what I wanted to say also here, if you look at this, you can see the URL here, the data, and we have do not sign request set to false. So we could actually say here, do not sign request, and then we wouldn't sign it. It wouldn't work with this application anymore, because we would get that error that you must sign your requests. We did this. Okay, we got a new data. I forgot to change this, but okay, that doesn't matter. So sorry, we do test and get the list. So now we should get only one data, because we are filtering now by the identity. So yeah, that works. I don't think there's anything else. Okay, so, and again, we did not change when we did the get list, get on this, because we always sign in every request that we do to any web service. So automatically got the identity. Next one is we're going to build a desktop app. So this is a very early of the desktop app, but it's more about how simple build a UI, simply describing what you want. Yeah, so let's just start. And this doesn't define what type of platform you're running on or anything like that. It just says, you know, let's start a window app. This could be Windows, macOS, Linux, Android, iOS, TV, doesn't matter. It just depends on what the compiler on the other end is gonna, you know, give you. What we're gonna inject as the module generator, basically. So we're gonna start the window app, and when we start it, we want to call the to-dos goal. So let's create a to-dos goal. So create a UI folder. Now the reason for this is because when we have UI stuff in the UI folder, is it gives the LMM kind of sign that, okay, now we're going to work with the user interface, focus on that module. So when we are writing stuff, you know, that's probably the module you want to work with, the UI module. So to-dos goal, we're going to create that to-dos goal. Here you can see we have a SQL statement. This is obviously not a UI module. This is going to be a DB module. But here we have button name add task, and we want to call this add task. And we say, okay, we want table for the variable to-dos, which we selected here from the select statement. The header of the table should be these task, category, and due date, and the body is going to be the properties of each item inside of the to-dos is going to be this. Now we are using Bootstrap. For this, I mean, it generates to HTML, and then I'm using Bootstrap as the template engine. And then mostly, you know, just native kind of JavaScript. It is using that Bootstrap JavaScript library. Can't remember what it's called, but yeah. Anyway, okay, so we have that. So we have the add task, and let's just build that and see what happens. So first of all, yes, it uses DB module to select from the table. Okay, figures out here, there is a column here completed, set it to false because we've said we're not completed, and order first. So this SQL, if we open up this, it's going to be, yeah, ordered by created task, you know. So, you know, it makes sense. And this is, as a programmer, you kind of should look at just to validate that the LMM is doing the right thing. You get a little bit careless, and you kind of stop doing it after a little bit of time, unfortunately, but then, you know, your app crashes and fun. So then we have the UI module. There's one function in there called render HTML. It can have kind of 3 parameters: HTML, CSS, JavaScript. For this, it's just a button. So if we open up this, we can see the button, and it's actually when you call, when you click it, it calls a function called call goal and add task. So call goal is always injected into the HTML. This function is always injected there, and it actually calls a goal in the Plang code. Then we have the HTML, and if you look at that, it's going to be this code here, and it's using a Razor template engine that .NET has, and it just goes through each item in to-dos. So this is to-dos. It has here task, category, due date. You can do things like, I just want to have it because due date is a date time, you can do it like this, if you wanted to have it like that. Anywho. Okay, so we have that built. There's one other thing we want to do, add task goal. So let's put that in here. And we have this. We are simply saying, see how simple it is. We just add a form with two inputs, task and due date, and one is required. This one is date, and we have a save button. Task created this. I haven't created this goal, so it's not going to work. And we want to, send these parameters into that goal. I'm also showing here how you can kind of call other goals to inject into this page. So when we click the add task button, you're going to see the form, and then you're also going to see the to-do list below. That's kind of demonstration just to see how you can inject other goals into your layout. Okay, so the next one is we want to build that. Did we build everything? Let me see. Okay, and now we want to run, and we have to run not Plang. So if we run just Plang, we are going to get this error message. And error message is here, incorrect output stream. You probably ran command Plang run, and you should have run Plang W. This is because we need to have kind of separate runtimes for window application and a console application. So you need to have Plang V. I would love to kind of not have this thing, but it is what it is. So we run that, and up pops the window app, and we can see what we described. It looks fine, nothing wrong with this. Fine task app for me. We add the task, and as I said before, we have the form here, we have the button, we had the call to-dos, so we have that coming here below. So, and when I ran, I actually got here the Bootstrap CSS. We also have Font Awesome here, so we can use that. So you could say save button, save icon or icon, something like this, and LMM will probably figure it out. So it will add that icon, save icon with. It's quite cool what it will figure out for you. Okay. Now the question, well, can you control the design? Control it. You can inject into the LMM request a template, and the template that the LMM should kind of follow. So if you have a design from a designer that has a HTML, you can inject that. So maybe that would be, a file. So you would say read HTML, or from the HTML folder design, or let's say form design.html into form design. So then you would get the content of this form design HTML into this variable, and then you could say, use template, and it's good to kind of, this is the template, form design template. So this would then be sent to the LMM, and form design would contain the template that you want to use, and the LMM will kind of use that to construct your form if that's what you want. But the way I see it, if you notice, we are running this all on a local machine. It allows the user to kind of change the design of his own app. He can build and change how the app looks. He can move buttons around. He can access data that he wants. So this will allow users to kind of be in control of what the app should look like, and not some designer with the company that creates this service. So that's very, very powerful because it gives the power to the user and not the company. So even if it's important, yes, the design, I'm not saying that, but functionality is always trumps kind of design. So I think this is more powerful. It is incredibly powerful for the user to be able to do this. Okay, so we created the window app. And let's go into rethinking how we design apps overall. So if you watched the previous video, I mentioned how you create a task list with pen and paper. Like, what's our natural way of doing this? I mean, we just write things down, and it's formatted for us. We understand it. We just read it and we understand it. We can't really do that with computers. Just like here's a text area filled with task lists, because then the data is not structured. And computers want structured data, because if you have structured data, we can actually work with that data. So that's why this idea of input forms, one field for the task, and another field, and so on, another task for the category. So you always have to click around, and you need to move, and all. So what I have kind of discovered is that the computers can now start to adapt to the user. So we can basically take that pen and paper example, and we can move that into the computer world. So let's do this. So go to the API folder and create a new directory called LMM. Okay, let's do that. So we are here, and let's create LMM. Now, why LMM? We know that this is all related to the LMM, and we are going to create here system.txt. This is going to be the system command that is going to be sent to the LMM. The reason why we do this in a text file is because then it's much easier to kind of modify this text and play with it, rather than putting this right into the Plang code. I'll show you that a little bit. So we need to create this new LMM task. So let's do that. Okay. Copy. Okay. So what we say here, read file lmm.system.txt, write that into the system variable, and load the variables. Load variables. Okay. So so that means basically it's going to read this variable that we have is actually this one here. Now this is the datetime variable in Plang. If you had some other variables available, you could have them also here, but we only have now at the moment. So now we have this long text file where we can kind of modify that as we will, and we inject it here. So instead of having, we could also have done this. No, we could have done this kind of a setup. But every time we would want to change this, if we just add a period here, we would have to rebuild the whole Plang code. Now that's just going to cost us money, so what we do is we actually load it from the text file. Now we can change whatever we like, and we don't have to rebuild the code. So this is the system command. The user, that's the task list that we are going to write down on our paper. And we are going to define here the schema. So this is actually kind of semi-JSON schema. It says it's going to be an array of items, and this here is the item. The item is a task, a due date, and category. And then when we get that data back, we want to write that into the task list variable. Okay. So then next step is just to do for each on that task list. Now you can write this loop through, go through, or whatever, just the intent that you want to go through this list. And we're gonna call save task. And then for each item in this task list, automatically you have, when you do a for each, you have default values. You have item, you have list, you have position. That's the index. That's the index of the item in the list, but the index starts from 1, not 0. And you have list count. So that's the how many items are in the list. Now let's say that you want to kind of use a different word than item. So item.task. So instead of item, we want to use task. We want to define the variable task. So we then would say it like this. And now instead of item here, it will be task, task, task. Okay. Yeah. Okay. So let's build that. And we see here it's going to ask, for some reason I don't have this cast, there is probably some space or something that I don't have precisely the same. So it actually went to the service and asked GPT or LLM service what module. Find the module for this. Aha, I found it, it's going to be file module. Oh, okay, so it actually did that, file module, read text file. And again, you see how descriptive this is. It's read text file, it's not just read file or read. Okay, so that is then built. Okay, excellent. We also want to kind of undo this and just have a start web server. Let's rebuild that also. And we want to change this, or actually create a new test file for this. Tests. Okay, we want this, we'll paste this in, and here we are posting to this service, and here we are doing this kind of paper version of the task list. We're just writing down our toothbrush, new oil for the tomorrow, to the boss about salary, but 2 days before the end of the month, and solve the credit card payment in the system. This is some programmer, do that should be done in 7 days. Yeah. And we have here a timeout. The reason for timeout is because, you know, the LLM can take a little bit time, sometimes more than default 30 seconds. So just put 2 minutes. Write results. I don't think it returns any results. No, it doesn't. So it's just going to be an empty string. Well, let's actually just from. So you can see here I'm using sheet. But you know, for those who don't know it, manage kind of well. So let's do this. So we will actually have write out to-dos. So when we actually do the request, we will actually get a response. So now it's actually building this. And you can see it costs a bit of money. DB modules are the most expensive because it actually does 3 requests or 4 requests actually. The module itself does 3 requests. There's always the first one to find the right module. Okay, but that all looks good. It's selecting from and this from the identity, and then it writes out the thing. So I believe we can now call this thing and we would get the results. And so let's try that. We need to start the web server again. And let's see this if this works. Yes, it should. Okay, so now we have, of course, the first item we did in the beginning of the where we used the identity for the first time. Then we said, well, we want to buy toothbrush, we want to buy toothpaste, and if you look at the system SQL, we have set default 2 days from now. That's why we provide the now here. And we have the categories are here that we wanted. So yeah, it's home by toothpaste. It's 2 days from now. It's fit. It's the 8th of March, which you can see here. Oil for the car, that's tomorrow, like we said. Talk to the boss out 2 days before. It's not really 2 days, but you know, it's good enough. And solved critical payment. So yeah, now doing this, if you're a programmer, it feels scary and dangerous. You know, are you going to get the data that you want? Are you going to get the results that you want? So from my experience, actually, you will get the data that you want. You will get the structure of what you want. Like we had here with talk to the boss about salary. It's not 2 days before the end of month. It's actually not that critical item. No, you want to be sure. You can always do that extra validation before you save the task into the table. It was also pointed out that it happens on midnight. Now you could always change the system txt and say 2 days from now at 23:59, you know, or 12 p.m., 12:59 p.m., whichever version of time you prefer. And then it would all be, you know, at that 12:59 kind of sorry, 11:59 should have been. Yeah, so that's about it. I believe that we've gone through the tutorial. And if you want to continue investigating and looking at Plang, what I would recommend is going into the repository here and going into tests. So there you can see tests for all of the modules in the system. You can then see how it's used. For example, here you have file, and here we are reading CSV files and Excel file. So let's go into file goal. So here we are reading image into a base64 text file. We are actually reading Excel file here, looping through it, CSV, looping through it. So you kind of have examples how to use things. How you generate code. If it cannot find a module for it, so here I am, for example, defining code in front. So I'm using the code module immediately because I know there's no module for this. So kind of like, you're getting the first name from name. It's gonna split this up. Yeah. So check out the tests. Then, of course, all the documentation that is there, you should be able to kind of hopefully navigate through that. If you have any questions, come by our Discord channel, come by our discussion forum here on GitHub. That's actually kind of best because that gets indexed, and well, Discord is just lost kind of. Yeah, and yeah, so go through this, see what you can learn, and yeah, and hopefully you like it, and hopefully if you like to participate and help building this, that would be great. Thank you very much. See ya. Bye bye.